together with colleagues from Aarhus University who have been part of the validation of the impact of the use case of the robot. In general, what we have with the robot as an implement carrier is the ability to use a number of standard implements known by farmers today, especially focusing on seeding and weeding operations, where the accuracy and the precision, and as you can see with the putting a drill right now in the video, the robot is built around the implement, thereby having the robot in the center of our control system, that we move the robot around its implement instead of having it in front or in back. This enables us with a higher accuracy, even though it's the same GPS systems as we would use with a standard tractor. The operations we show here is also to show that we can use different types of brands, different types of models of seed drills, and again using them together with different kind of weeders, as we will you have the ability to see in the fields running outside right now. By using the robot, kind of like that platform, designing it around our implements, gives us the possibility also to use less weight, because we don't need the counterweight of a tractor with an implement in the back. We use the implement's weight to make the complete machine set lighter. Thereby we are able to save energy comparing to standard tractor machine setups. We are also able to do a more intelligent planning, so that's where our route planning software enables possibility to do the field coverage in a more optimal way than we see done with farmers. So that's where we see that depending on field size and shapes, we can always do a minor, but we have potentials up to do 20% higher efficiency in the coverage of a certain field area. These are some of the few benefits we have from it, but the specific example we will like to present a bit more in detail today is a Danish conventional farmer, so a standard farmer doing arable production. The robot is at the farmer used for seeding maize for maturity, so not silage maize, but maize for maturity. As you can see in the tracks of where the robot is driving now, it's not doing a track by track, but doing this route planning, so it makes sure that it's covering with the optimal turning radius, etc. in the field. You see it running with the standard 4-row Gaspardo drill as part of this equipment setup from this farmer. Beside the 4-row precision drill, the farmer also has a mechanical weeder, a standard Kongskeller mechanical row weeder, and then a special designed band sprayer that's developed by the Danish sprayer manufacturer Danfoil, where he's using the Danfoil sprayer as band spraying in his conventional setup, thereby enabling potentials directly by not spraying the full area, but only spraying the area on top of the maize, and then combining that with the mechanical weeding in his setup. On board the robot, we have a number of camera systems. They help the farmer to get insight into what is happening. So the top picture to the left is one of the surveillance pictures that is already on the farmer's interface. So you have a front view camera, you have a rear view camera, and you also have a view camera that looks down upon the implement, so you can always feel comfortable what's happening in the field. And as now these are 3 different screenshots from the user interface. In the bottom, we can always see how much of the field has been covered and where is the robot actually at this point. In the second screenshot, we always can see how much of the operation has been carried out, when is the expected finishing time with the planner. So that gives the farmer the ability to plan when to go to the field to pick up the robot or move it to the next area. But beside the camera here, we also have a camera not looking down upon the implement, but looking down just in front of the weeding tool, where it's gathering pictures of the weeds and the crops in the field. And that's where I've brought my colleague, product manager Gareth Edwards, who will take us a bit more into the data mining possibilities that we have with the robot.
Hello. Hello. Yes, my name is Gareth Edwards, and I'm the product manager for the digital infrastructure that we have on ROBOTTI. Yes, so as Olga explained, we have our cameras here, and this is a screenshot from the mobile phone app that we have, which you're able to use to monitor to what ROBOTTI is doing. During the course of the operation, we have taken a number of images, which are then uploaded to our server. Here, all the blue dots are individual places in the field where we have taken these images. We upload them directly to our server, and as they're being uploaded, we do an image processing on them, where we're able to identify the weeds and the plants. We can identify monocots and dicot weeds, and we can identify a number of crop species as well. So here on this interface, you can see the red marks indicate the days when he went out and serviced, and as the blues are the images. Each one of those images is you're able to click on. You're able to click on and get a close look at what the ground conditions were. Because we're wanting to automate this whole process, we're taking the farmer out of the field. In doing that, they lose that interaction with the soil. But by giving them this system, they can we allow them to gain insights into the different parts of the field. Often, if a farmer was doing this work, he might walk in to look at the soil conditions, maybe in the part of the field nearest the gate, and walk around and take a bit of a stroll around a bit randomly to work out what the conditions in the field are. However, with our system, he's able to do it systematically. We've covered the whole field, and he can do it from the comfort of his own home at any time that he wants to. So if you look closely on this image as well, you will see the segmentation of the crops. The crops down the middle of the line have an orange circle, and then the weeds all have a blue circle. So using those counts, we can make aggregated maps. So we can make aggregated maps of where the crop density is in the field. He can check that the seeding worked out as he planned, and that he has a nice even coverage of crop. And we can also then plot to get where the weeds are. So this is then a map of the crop coverage. As you can see, it's fairly even, meaning he got a good result from his sowing, so he should be fairly happy with that. And then this is the plot of his weeds. Again, as you can see, there's probably two concentrations of weeds across the top of the bank, which is it's next to a road and under some trees, so that's likely to be some encroaching from weeds there. And then in this other area, which is heavily trafficked, because that's where the gates are, so that's also been susceptible to weeds. But as you can see, the majority of the field, there's no weeds at all. So what would normally happen now would be he would go out to do a weeding operation and again cover the whole field. But that's wasted energy. That's wasted interaction with the soil. By moving the soil, he could be losing moisture from it, which could be affecting the crop as well. So what he's able to do is create an application map, but for weeding. So he can take this and set a threshold on what his limit is on the number of weeds, and he can bring this back into our planning software. Oh, yeah. So he can set a threshold on what percentage of weeds could be coverage, and then he can bring that back into our planning software. So this was the original plan with the route for the robot, and then as you can see, he's able to make a new plan for the robot, which is significantly shorter than the previous plan that he had. And also, it's only putting the implement down where it's needed. So he can cover this whole field in a fraction amount of the time using a fraction amount of the energy. This actual study was done as part of a university project, but it's using a product that we have as standard now on all of our ROBOTTIs. All robots come with this downward-facing camera. So any new customers of ROBOTTI are able to utilize this to do these site-specific weeding operations if they so wish. So then there was a final analysis which showed we were able to make savings, huge savings on both fuel and on time spent in the field, up to 97%.
So for us, the main driver in the work of this is basically, we know when we take out the farmer from the field, we are not spending the time today, we're sitting in the tractor looking forward. What we would like to enable with this kind of technology is giving the farmer the possibility to go back, actually being the one that has time to look at the soil, to actually be the agronomic expert as we foresee. And that's where we see the robot is that possibility to remove the uniform repetitive work and basically bring our farmers' time back to being the agronomic expert, as we believe is the right way to do it. So what we see is, for us, definitely the robots is a possibility today. And what we like to show with the presentation like this today, and we would be happy to give you a much more insight into this and the possibilities with the data sharing from the robots to the farmer through multiple platforms. That's where we see with the precision and accuracy that we can obtain with the robot today, we're sure that these are solutions that have come to stay and will benefit also the farmer in the near future. Thank you very much for your attention.
Thank you very much, Gareth and Holly. This is really precise information, as you can see, very, very, very precise. Many, well, questions here? Yeah, maybe. You need a
Hello, my name is Constantino Valero from the Polytechnic University of Madrid and with some other colleagues from the academia here. We have seen very clearly the advantages, but I would like to ask you about the drawbacks, the barriers in adopting these technologies, because for us from the academia and from the demonstrations that we like to do to the sector, it's quite difficult to convince them. So what's your point of view with your experience with Agrointelli?
Well, you're addressing a very urgent point in, I would say, not only our case, but in a lot of cases. Today, I think showing savings like this address very much into the sustainable agenda. We need to convince a farmer to do a behavioral change to achieve kind of like some minor savings, because the major savings in this is not the digital farming. Because when we talk to the farmers, they see the benefit here. But we have one major key selling point today, and that is they start looking into the robotics if they are challenged in labor force. All the smart tech is something we can start discussing on top of that, but we won't get them into dialogue before they are suffering in getting a tractor driver. But when they are lacking a tractor driver, then we can get into this possibility. Because also both Gareth and I have a background from academia. We love this because we can see there's so many sustainability aspects in this. But farming business today is a marginal business, so they'll not take the risk from small sustainable gains. Their core business is they need a reliable tractor driver. And if they can't find that, then they see, okay, what's the alternative? And I think that's the big change today, but also what we've seen in the last 5 years, all over Europe, all over the world. We see with the guests here today, the main pain that's been addressed is that it is harder and harder to find people that's willing to sit and do the uniform repetitive work. And when we then get them into dialogue, then we can kind of like get to the next stage.
Thank you. Yeah, a question? Introduce yourself, please. Yeah.
Good morning. I am Davide Ricauda from the University of Turin. Thank you for your presentation. Just a question about the safety. What kind of safety devices are you implemented in your machine today, or you will be implement in the future?
The core of the robotic today is it's navigating on GPS. So from the point where we say the robot is not allowed to run off or run outside, the basic is geofencing. But when we start looking at interaction with humans or other movable non-permanent obstacles, we are using today a laser range scanner together with camera technology, and then we have a physical bumper system as kind of like the third last resort from a technical perspective. But what we have been looking into is also how we can utilize technology from automotive. And that's why we will be launching here in 25 an upgraded version where instead of the Velodyne laser range, we will go into radar, because now we can acquire safety certified outdoor radar components, which helps us in our performance levels, so that we have a complete system that has a higher performance level. So that has been an important part, but still combining camera, bumper, and in the future radar technology.
You may have some actors here as well about DNS and security and safety. Yes. So I'm sure you may work already with them.
Yes.
Yeah, you'll see. We just heard Hexagon just before. Yeah, well, this is one of the actors also who can help on that. And other question first? No? Question? Tons of data. Because tons of data.
Yes.
Huge amount of data.
Yeah.
How you explore this? Do you use IA in? How you help users with this data? You've got a platform. What is your solution about that? How long you're going to keep this data? Because it's an amount day per day of information. So when you collect it, where are they? I mean, you know, this is an environmental question as well.
Well, taking the last part first on data. We have three main costs on data. Acquiring the data from the robot can acquire tons of data. So we need to be very, taking considerable choices on what is the data we'd like to store. So the uploading of data is one cost. Storing data is another. Relatively cheap today to store data in the cloud. What also is a cost that's often forgotten is the processing of data in the cloud. And that's actually where what we do today, whenever the robot's in the field, we transmit and we store image data with a certain resolution, where you can see like with the blue dots in the maps. And then on request, so when the farmer says, now I'd like to see my weed intensity from this operation, then the farmer requests an enhancement of the data. And that means that the servers that start running with the neural network, the AIs, to do image analysis of all the images, making the map out of it. So that we are trying to not spend server time in processing images until we need them. So that's part of it. But basically the amount of pictures has been based on a number of research projects to say, how do we obtain 95% confidence interval of having the variance of the field, because if we should take all weeds, we would need approximately 12,000 pictures to cover the full area. So that's why we're looking at what is then the needed number of pictures to get the right interval. So that has been part of the research ongoing for the system.
Thank you. Yeah, it's a selection of to improve your system. Okay. Other question? Well, we may ending now the day. Thank you very much for this last presentation.